You ever stop and think about the invisible engines of history? The bits of technology that were so fundamental, so world-changing, that eventually they just kind of faded into the background. Well, today, we're going to pull one of those forgotten giants right back into the spotlight. Okay, take a look at this place. This massive industrial complex in Bayonne, New Jersey, was an absolute global powerhouse. But its product wasn't something flashy like cars or airplanes. Nope. It was building something way more fundamental. Something that made all that other stuff even possible. And this wasn't just a one-off. The company behind it, Babcock Wilcox, had these huge operations all across the United States and all the way over in Scotland. Their industrial might was just staggering. So what were they shipping all over the world? Boilers, the actual heart of the steam age.
But why? Why was there such a huge demand for boilers? What was the big problem this industrial giant was solving? Well, to put it simply, early steam power was terrifyingly dangerous. The whole issue came down to the immense, and I mean immense, pressure needed to make it all work.
This quote from a Dr. Thurston, wow, it really gets to the heart of the fear. He isn't talking about a small leak here. He's talking about a general disruption. Basically, a catastrophic failure that unleashes an unimaginable amount of energy all at once. Early boilers were, for all intents and purposes, ticking time bombs. So the old designs, these things called fire tube boilers, were just riddled with flaws. All the water was in one giant tank, so if it ruptured, the whole thing went. They also suffered from these unequal strains because different parts would heat up at different rates, literally tearing the metal apart from the inside. And on top of all that, they were inefficient and a total nightmare to repair. A new design wasn't just about making things better, it was literally a matter of life and death. So, the big breakthrough, it didn't come from just using thicker steel or bigger rivets. The solution was actually way more elegant, and it was based on a simple principle of physics that you've seen 100 times in your own kitchen. The secret? It was all about mastering circulation. Seriously, just think about boiling a kettle of water. The water at the bottom gets hot, it becomes less dense, and it rises. Then the cooler, denser water from the top sinks down to take its place. This natural movement is called circulation. The engineers at Babcock Wilcox realized that if they could control and supercharge this process, they could solve the biggest, deadliest problems of steam power. And the principle is just beautifully simple. If you take a U-shaped tube filled with water and just heat one side, the water in that leg gets hot and rises. The cooler, heavier water in the other leg then falls to replace it. And just like that, you get a stable, continuous circulating loop. And the best part? It's all powered by basic physics, no pumps needed. This one idea, circulation, was the absolute game changer. Why? Well, for one, it's incredibly efficient at transferring heat, and by keeping that water constantly moving, it ensures the entire boiler stays at a nice uniform temperature, which gets rid of those dangerous expansion strains we talked about. And of course, a more durable boiler is a much, much safer boiler. The real genius, though, was in how they scaled this up. Babcock Wilcox designed this incredible system where water flowed through a whole array of inclined tubes. Hot gases from the furnace would heat the tubes, driving this powerful, continuous circulation of water up into a collection drum. They took that simple little U-tube and turned it into an industrial powerhouse. So by putting the water inside the tubes instead of around them, Babcock Wilcox created what's called a water tube boiler. And to really see why this was such a revolution, let's put it head-to-head with the old fire tube design. I mean, the differences here are just staggering. Let's start with safety. If a water tube fails, it's a local, manageable event. It just vents some steam. A fire tube rupture? That's a building-leveling catastrophe. Then look at the speed. A B&W boiler could get up to full pressure in under 30 minutes. The old designs, they could take an entire day to heat up safely. The new design was also way better at handling high demand, and repairs were as simple as swapping out a single tube. It was a massive improvement across the board. So you can see this wasn't just a small improvement. This was a quantum leap forward that unlocked a completely new level of power and reliability. And it showed up at the absolute perfect moment in history. But here is the most critical feature of all, its flexibility. Because the circulation was so good, these boilers could be safely pushed to run at over 300% of their official rated capacity. This ability to handle sudden, massive surges in demand, well, that was about to change everything. And that ability to handle peak loads was exactly what the brand new, booming electrical industry desperately needed. Think about it. Power demand in a city isn't constant, right? It surges when factories start up in the morning and when everyone turns their lights on at night.
These boilers could handle that rhythm perfectly, which made them the go-to engine for the new age of electricity.
And inside the power stations, this is what it looked like. Just rows and rows of these powerful, reliable boilers became the beating heart that lit up entire cities, ran the streetcars, and powered factories all across the globe. This right here was the engine room of the modern world.
So from the biggest cities to the most remote industrial mines, this safe, efficient, and powerful boiler technology gave the world the dependable steam it needed to drive the incredible progress of the 20th century. It just became part of the invisible, essential infrastructure of modern life.
Which kind of leaves us with a final thought, doesn't it? The Babcock and Wilcox boiler is the perfect example of a foundational technology that becomes so successful, it basically becomes invisible. It really makes you wonder, what are the equivalents today? What are the unseen, uncelebrated innovations that are quietly making our modern world possible right now?